Our next question is, the sun rotates around its center once in 75 days. What will be the period of revolution if the sun were to expand to twice its present radius without any external influence? Assume the sun to be a sphere of uniform density. So days are given, so we need to find out a new time. The question seems to be framed on gravitation lesson, but it's not from that. It is from rotational mechanics. So here the object is rotating, the sun is rotating. Sun is rotating in such a way that for one rotation it is taking 27 days. So time of rotation is equal to 27 days. So after that, what happened? The sun were to expand to twice its present radius. So earlier it is r, and now it has increased its radius to 2r. Now we need to find out the time of rotation. Okay. So what are the relations for that? So you might have seen the application of moment of inertia, angular momentum concepts in rotational motion. In that, one example is there. So if you have two dumbbells or two weights in your hand, and if you are sitting in a revolving chair, if you rotate about that using that chair, if you rotate about itself, then when you are holding the hand near to you, the velocity increases, angular velocity increases. If you stretch your hands, the angular velocity decreases. That means when you are increasing the radius, your velocity changes are there, increasing or decreasing the changes, velocity changes are there, but the only thing is angular momentum is conserved. The angular momentum of that body is conserved, and you don't have external forces acting on it to rotate the chair also. So that means in that case, when you are not having any external forces, that's what is specifying here, without any external influences. So when you don't have external forces, your angular momentum is going to be conserved. For example, that means the I omega is constant, or I1 omega 1 is equal to I2 omega if you compare two situations. So if you divide 2 pi with this, the expression will become I1 by T1 is equal to I2 by T2. So what is I1? Moment of inertia of this spherical object. So at first it is 2 by 5 mr1 square, make it like that, by T1 is 27 days, which is equal to 2 by 5 mr2 square by that's what new time we need to find out, T2. Okay, 2 by 5 m, 2 by 5 m to cancel on both sides, because mass is not going to change, because even if you keep your hands here or if you stretch your arms, you are not going to increase or decrease your mass. So that's what it is. And even says that sun to be a sphere of uniform density, it is maintaining the whole body, it is maintaining uniform density, so your mass will be equal. Yes, there is a conflict according to volume, but according to the given situation we need to put the expression. So these two gets cancelled. R1 square by 27 is equal to R2 square by T2. If you reshuffle that one, you will have T2 is equal to R2 by R1 whole square into 27. So R2 is double of the R, so you will get 4 here. 4 into 27 is equal to 108 days. So then in the second case, sun rotates around it in 108 days.